invite Dr. M. Abdul Kader, Principal Director and Head, CIPET, IPT, Ahmedabad. Welcome, Dr. Kader.
Yeah, thank you. Thank you, Mr. Kamal Sharma, for introducing me nicely. So I represent the CIPET. You know, the name itself has the plastic in its title. So I need to have some positive I need to tell something about the positive aspect of plastics also. At the same time, how we can alleviate the problem which are generated through a particular section of plastics which is going into the landfill and thereby creating a lot of issues. So if you see that now, the plastic has become inseparable part of our life. We use from the morning to night in different forms and different shapes and different applications. So now people feel that if they are asked to completely omit or stop using the plastics in their life, it is very difficult now. So we have been given test of using something for comfort, and that is now become part of the life. So now the issue comes when how we are handling the plastics, how we are going to effectively utilize the plastics. So when plastic came, there was no such a resistance that it should not be used. And you know that over the period of time, when it is going to be a nuisance from the point of public as well as from the point of government, with respect to the use and their disposal. So obviously it is understood that plastic is not a degradable material. The intent for making plastic is to make it to be useful for long life. So obviously the chemical structure and then the scientific principle says that plastic is not a degradable material. It will be stay there for decades and then even the centuries. It will be there. But how to make use of these plastics again and again? That's what the things will come, and then technologies are needed for such a things. So from the CIPET, we also do a lot of research on the development of newer plastics for very specific application, ranging from the normal use to the advanced use, which are for the electronics, telecommunication, aerospace, and the composites having the strength equivalent to the metals and other things. So those things, researches are going on towards the development. At the same time, we do research on how to recycle effectively the plastics which are gone out of the end use, or it has gone to the landfill, or before landfill it is going after completing it life cycle. That is one way. And second recycling process, we always carry out the pre-consumer waste which are generated from the industries which has some virgin properties. Those things are also, we are doing a lot of things. And in this, the technologies which are being implemented in the case of recycling, though there are so many methods are available, chemical recycling, mechanical recycling, and also getting energy through the tertiary and quaternary type of recycling, everything where we have been doing. But the technology what we have present in our country is not so adequate to satisfy or make suitable for the recycling technologies. So it starts from the collection, segregation, and cleaning, washing, and then coming to the specific product, specific material, plastic categories, and then finally converting them into either product or granules, which may be further processed for getting a product. And the technology we lack in the case of segregation and sorting, where the advanced countries are having the new technology, where the plastic can be segregated based on their density, based on the KL, based on the chemical nature, using different methodologies and technologies. That is happening. But right now, we in the technologies using near infrared technologies, where it can be segregated based on the colors and then densities, and using there's a magnetic separation. Many more technologies we need to follow. This is one way. And second way, in order to prevent the plastics coming into the mainstream for large quantum of use, where there is a problem of degradation and the recycling, it is also preferred to have a kind of plastics which may undergo the biodegradation or composting or similar kind of plastics, which are all given a specific scientific input for their programming, like the polymer molecules might be made with the programming so that it will have a period of life for certain time, maybe 10 years, 15 years, or 20 years, that can be programmed. So that research is also going on in this direction. Other than that, if you talk about the end use, that is the end of life plastics, how to recycle in that way, and also before going to the end of cycle, how the material which are termed as a single-use plastics, which cannot come into the mainstream later on. And government has given the, what you call in the new plastic waste management rule, that the thickness of the plastic should be minimum 120 micron from July 1st onwards. So in that case, the existing processor who are manufacturing the plastic bags or plastic packaging material, they need to be sensitized with what kind of technology which will be available in the future for making the thick plastic films, so that they will not face any kind of technological problem in their manufacturing. CIPET is also providing support for the technology development for converting the existing machine which are designed for making a thin film plastics, which can be modified with some process parameters or design parameters or kind of modification which machine needs, so that that same machine can be utilized for making bigger. There's a thick plastics which will satisfy the plastic waste management rule. So those things are also we are taking care, and in fact we are conducting seminar in the case of what you call the alternative material for the plastics, so there is single-use plastics, so that the benefits of plastic can be retained. At the same time, the nuisance of plastic from the packaging material can be alleviated or removed. So these are the research activities that CIPET is carrying out with the support of ministries and funding agencies, and also private agencies who are interested for developing biodegradable plastics. So many industries are approaching for biodegradable plastic testing as per the ISO 17088. We are doing the testing support for those companies and certify them if the product is compostable as per the ISO standard of 180 days, by having a controlled amount of cellulose. So those supports are we are providing, and some parties are also coming with innovative ideas for developing the biodegradable plastics from the bio sources which are available. So that type of support we are also doing. So in this aspect, we are also concentrating on the product design aspects of the plastic, so that their end use will be limited for a certain period, or there will be an alternate material from the bio sources which will substitute with the conventional plastic which are generated from the petroleum sources, which has the limitation of biodegradation. So in all these aspects, CIPET is supporting the general consumer, manufacturer, producer for getting some betterment in their aspects. So I think that the information regarding the CIPET activities may help the audience here. And if they need support for this kind of activity, they can approach the CIPET. And we are also the part of mainstream the program of the that is plastic waste management. We have Government of India, our ministry has given fund for setting up of 4 exclusive center for plastic waste management in Ahmedabad, then Bangalore, and in near that there is in Patna, and one more place. So the 4 places, the center will come for giving the technology support for the plastic recycler for managing the plastics. So with this, I thank the organizer for giving me the opportunity for discussing about CIPET role in plastic waste management. Thank you.